Okay, let's dive right into this. Welcome to today's Explainer. We are breaking down the absolute most critical insights from the Next in AI newsletter. Look, if you're an analyst, a venture investor, or a corporate exec, you already know how blistering fast the space moves. So today, we're giving you a high-level 360-degree executive briefing. We'll hit the boardroom shifts, the emerging tech, and those massive lab breakthroughs that are literally defining the future of artificial intelligence. We've got a ton of ground to cover, so let's get right to it.
$740 billion. Just let that number sink in for a second. That is the amount of capital expenditure big tech has announced for this year alone. It's a massive financial stake being driven straight into the ground. And honestly, here's the real kicker. They are making these historical investments without widespread evidence of increased bottom-line productivity just yet. We are witnessing a monumental bet on the future. So, how do we actually make sense of all this?
Well, to unpack that $740 billion question, here's our agenda for today. First, we'll look at the business of AI. Second, hardware and model efficiency. Third, new models and integrations. And finally, we'll wrap up with the global AI divide.
All right, part one, the business of AI. We're talking boardroom shifts and capex realities. An executive at NVIDIA recently dropped this quote, stating a pretty stark reality. The cost of compute is far beyond the cost of the employees. I mean, think about the paradigm shift that represents, right? Historically, human capital has always been the primary expense for technology firms. But today, simply keeping the machines running and the models processing is actually more expensive than paying the incredibly smart humans who build them. And because of these massive costs and the absolute sprint for market dominance, corporate alliances are shifting, and they're shifting fast. Take Microsoft and OpenAI, for example. Their famous partnership, which practically everyone called an exclusivity agreement, it's cooling into more of a situationship. Most notably, a specific clause regarding artificial general intelligence, which really dictated the future of their deal for years, has been officially dropped. The boardroom commitments are becoming decidedly less committed as both of these giants maneuver for strategic advantage.
And, we're already seeing the immediate business impact of these shifting alliances. Literally days after that exclusivity agreement changed, OpenAI's GPT models, codecs, and managed agents all became available on Amazon Web Services. This is huge for the market. It means enterprises that strictly require secure AI within their existing AWS environments now have direct access to OpenAI's foundation models. It's just a massive unlocking of enterprise capability.
Moving on to part two, hardware and model efficiency. Let's step inside the lab.
Right now, the AI ecosystem is urgently trying to balance some serious competing demands: scale, energy, and accuracy. First up, researchers are developing what they call carbon-taxed transformers. These are essentially green compression pipelines designed to shrink models that have just become unmanageably large, memory-intensive, and totally carbon-heavy. Second, there's this massive push for transparency. In super complex fields like particle physics, researchers are building tools to finally understand the physical reasoning behind complex neural network predictions, basically cracking open the black box. And third, we're seeing highly practical specialized tools emerge. Think large language models custom-built specifically to detect financial statement fraud. Now, all this research is absolutely crucial because, frankly, simply making models bigger just isn't the easy answer anymore. Scaling up large language models is actually hitting diminishing performance returns. But hardware is the ultimate differentiator right now. As the IEEE Spectrum noted, better hardware can literally turn zeros into AI heroes. Although, a quick heads up, if your company is out there renting compute, you really need to be careful. You're currently playing a silicon lottery because definitely not all GPUs yield the same performance.
But our interaction with these models goes way beyond just code and hardware. Researchers are studying this fascinating concept called lexical anthropomorphization. It's a big term, but it basically means using humanizing language to describe AI. The wild part is that when we use human terms, it actually shapes our moral judgments of the AI when it misbehaves, like when it hallucinates or makes totally inappropriate comments. The literal words we use change how we forgive or condemn the machine. Crazy, right? And speaking of interacting with the machine, there is a very distinct AI fluency paradox right now. Looking at recent user data, specifically a huge sample of 27,000 transcripts, there's a massive gap. Fluent AI users don't just do things faster, they take on significantly more complex tasks and iterate collaboratively with the AI. Novice users, on the other hand, barely scratch the surface.
It just goes to show that the true ROI of AI isn't really in the tool itself, but in the skill of the human wielding it.
Okay, part 3, new models and integrations. Let's talk about deploying these capabilities.
The perfect example of this unified capability is NVIDIA's newly launched Nematron 3 Nano Omni. Instead of juggling separate, clunky models for vision, speech, and text, this is a single open model that unifies the whole shebang. It's built specifically for massive-scale agentic workloads and boasts up to 9 times more efficiency. And incredibly, developers can already access this day zero via platforms like Together AI.
As these models become multimodal, their internal processing gets incredibly nuanced. Researchers have actually managed to map out exactly how large language models internally recognize emotion. It's this mechanistic, 3-phase flow, starting with syntax processing, moving through sparse feature activations across the neural layers, and finally resulting in emotion inference. We're literally mapping the mechanical empathy of artificial intelligence. It's mind-blowing. And that deep capability is sparking an absolute wildfire of commercial integrations across practically every sector. Just look at some of the recent product launches. Take Asterisk, which gives you instant AI color grading for film looks. Then there's Venture Factory AI. It can build a full venture strategy for you in minutes. PixArt CLI brings really powerful photo editing directly into your AI chat box. And at the institutional level, the MIT IBM Computing Research Lab just launched to jointly shape the future of both AI and quantum computing.
But, of course, with great capability comes significant risk. Recognizing this, OpenAI recently released a 5-part action plan for cybersecurity in what they're calling the intelligence age. The core tenets here are to democratize AI-powered cyber defense, vigorously protect critical infrastructure and systems, and deeply collaborate with global safety experts. The defense, you see, absolutely has to scale alongside the intelligence. Which brings us to part 4, the global AI divide, geopolitics and macroeconomics.
When we pull back and look at the macroeconomic and strategic reality, there is a profound divergence occurring right now between the United States and China. Analysts note that America currently appears unprepared for the advent of comprehensive world models, while China is taking a distinctly different, highly deliberate path in its AI development and implementation. This isn't just your standard technology race anymore. It's a fundamental divergence in policy, economic integration, and global perspective.
And the absolutely crucial point here is that this global divergence has sparked a frantic race for AI sovereignty. Both governments and multinational companies are suddenly waking up to the fact that they cannot rely on external black box systems. They are racing to build, own, and maintain absolute control over their AI infrastructure, their data, and their models. They are completely reevaluating their global strategies to ensure they aren't left dependent in a fractured digital world. Which really brings us right back to where we started, that $740 billion capex bet. That massive amount of money is being spent right now to secure the future. So I'm going to leave you with this provocative question based on everything we've covered in today's briefing. As compute costs soar, as hardware dictates the winners, and as the globe fractures into sovereign AI ecosystems, is your strategy prepared for the new era of AI sovereignty? Thanks so much for joining me for this explainer, and I'll catch you next time.